Hey there. In this video, we are going to look at how you can use the 3 reciprocal identities and 2 quotient identities along with algebra skills to simplify trig expressions. So looking at simplifying expressions using reciprocal and quotient identities as well as any algebra skills that we can bring forward here, I have several examples for us to look at. This first one, tangent theta times cosine of theta, that expression we can simplify a little bit. A good strategy to use often is to try and, if you have different trig functions involved, to try and use identities to either create just a single trig function or something where you can use some algebra. So the strategy we're going to use here is to try changing that to sine over cosine, because tangent is equal to sine over cosine, so we can replace tangent with sine or cosine, and then we still have that cosine there that's beside it. So this is this, and this we have changed into this. And then we're going to move forward with from there, because if you see here, what we can do is we have sine divided by cosine times cosine, and you're going to find that divide by cosine and times cosine, those operations are going to cancel out, so we can do this, and we are just left with sine of theta. So this original expression can be simplified to that single trig function. This second one here, we have secant times cotangent times cosine on top, and then divided by cosecant on the bottom. If we want to, we can try that same strategy of replacing things with trig functions to try and make it so we don't have so many different ones. And what often is a strategy that people adopt is change everything to sines and cosines, because all of the identities that you have, all of the reciprocal identities and the quotient identities, other than the one that relates tangent and cotangent, but the other 4 all are a way of replacing some of the trig functions with things involving sine and cosine. For example, secant, we can change it to 1 over cosine of x. Cotangent, we can change to cosine of x over sine of x. Cos of x, I am just going to leave it alone for now. And then on the bottom of this whole thing, let's make it clear where the big original fraction line is there. This is 1 over sine x. All right? So then we can start to look to simplify this a little bit. We can see that this cosine and this cosine, since it's divide by cosine times by cosine, those may well cancel out. And then I'm going to rewrite the top here. I'm going to rewrite that as cosine x divided by sine x. And then I have that main division line 1 over sine x. And then from there, what I can do is, since I have fraction divided by another fraction, what I can do is change it to that top fraction multiplied by the reciprocal of the bottom, which is sine x over 1. And then we can look at canceling those two things, because divide by sine multiplied by sine is going to cancel each other out, and we just have cosine of x. All right? That is one way of doing that. You're going to find different strategies that people use to do these things depending on what you happen to notice here. I'm going to take this original thing and I'm going to work down here. And what you might see is that you have secant and cosine on the top there. So the fact that you have secant x and cosine x on the top there, if you recognize these are reciprocals of each other, and you may well know that reciprocals multiply to 1. So what you can do then is say those two things are going to multiply to 1. So I'm going to just cross them out, cancel them right away. And I just have cotangent on the top. And you might decide to leave this cosecant on the bottom like that, so that you have cotangent over cosecant. And from there you might decide that you're going to replace some things with what we did over here, right? So you'd get to that step where you have cosine over sine divided by 1 over sine, all right? You might also decide that you're going to change this dividing by cosecant, knowing that dividing by cosecant is like multiplying by the reciprocal of cosecant. you may well say this is the same as the top thing, cotangent, multiplied, and so instead of dividing by cosecant, you may well just say, I'm going to multiply by the reciprocal of cosecant, which is sine, right there. And then you can go about changing this to cos x over sine x times sine x, and then it looks very similar to what we had over here. Those are going to cancel out, and you get to there. So there's multiple ways of doing all of these things. All right, let's look at another example here. So this one's going to be a little bit more involved, and I have several different methods to work with here. So this expression here, 1 plus tangent over cotangent plus 1, we're going to work at simplifying that down to a single trig function. So the first method we're going to try here is what I mentioned before in the previous example, is try changing everything to sine and cosine and see where you get. So on the top, 1 plus tangent, you can change that tangent to sine over cosine, like that, sine over cosine. And on the bottom, we can change this cotangent to cosine over sine. Now, the reason I haven't written the ones down yet is because now what we have is we have two terms here. We have 1 plus that, but if this is a fraction, what I might want to do is to change this into a fraction so that I can add these two things together. So what I mean by that is instead of that 1, we can change the 1 to something over itself. Or in other words, we can think about the 1 being the same as cosine theta over cosine theta. Cosine theta over cosine theta is 1, and the reason I would choose cosine is because this is the denominator over here, so now I have a common denominator on the top. And I would do a similar thing on the bottom, except that I would use sine as the denominator, because that would allow me to add those two. And then I have, from that expression, I can write them as one single fraction on each of the top and the bottom, so I can add those two things together, and I'm going to get cosine theta plus sine theta over cos theta. And on the bottom, let's make this line bigger just to make sure we realize that's the main division line there. On the bottom, we have cosine theta plus sine theta, but this time it's over the common denominator of sine theta on the bottom. So we have fraction divided by fraction. When you have fraction divided by another fraction, you can look at changing it to multiplying by the reciprocal of that thing that's on the bottom. So we're going to keep scrolling down here, and I'm going to write this as this fraction, cos theta plus sine theta divided by cos theta, but now multiplied by the reciprocal of that fraction. So this is going to be sine theta on the top and cos theta plus sine theta on the bottom. Now, from this point on, we're going to try and simplify this multiplication before we actually multiply it out. We could just multiply this by both of those things and this by both of those things, but we want to try and simplify it first. It's better to simplify it before you multiply it out, make things simpler. What we can do is look at, we have a sine on the top, we have a cosine there, and it looks like we have things here. We have a sine down here, but it's part of a binomial. Now, you might be tempted to say, hey, we can just get rid of those signs like that, but no, you can't, because this is not all by itself on the bottom. It's part of this binomial. If we're going to divide the top or the bottom by something, or in other words, we're going to cancel something, we need to cancel this whole thing. We can cancel with this whole thing, because whatever the value of theta is, those are identical, and they would divide out to 0. And that just leaves us with sine theta over cosine theta, which is, as you hopefully know, tangent of theta. So we've turned the whole thing into tangent of theta. Now, I said up above, I have another method here that we can do, and we're going to end up seeing that it turns out the same in the end, but the start is different, and you'll see that you get there a little bit quicker. If you happen to notice in here that I said earlier, look to choose a trig identity that helps eliminate the number of different trig functions you have in here. Since this one only involves tangent and cotangent, you can use an identity for cotangent to turn it into an expression that involves tangent. So what I mean by that is we can, on the top here, have 1 plus tangent, and on the bottom we can change the cotangent to 1 over tangent. plus something. Now, since I've turned this into a fraction, what I'm going to do is turn this 1 into a fraction so that I can add them together the way I did over here. So in this case, though, tangent's my denominator, so what I'm going to want to do is make this tangent theta over tangent of theta. And then I can go about, I'm going to leave the top the same. I don't need to do anything there because I don't have any fractions involved there, but I can add that together and make it 1 plus tangent over tangent. And at this point I can do what I did over here, which is change dividing by that fraction to multiplying by the reciprocal with what I have here. Tons of space there, but maybe we'll just squish this down a bit. So I'm going to do this just to give myself some more space, but don't necessarily want to erase it like that. Still read it there. So we have something divided by that fraction. So what that means is I can turn it into 1 plus tangent, the thing on the top, that thing right there, times the reciprocal of this thing in the bottom. Dividing by that thing is like multiplying by its reciprocal, so multiplying by tangent over 1 plus tangent. And then from there, I can look to simplify it. Now, I wrote this with brackets around here, which is important because you want to say it's this whole thing times this fraction. The other way you could do that is you could write this, maybe not with brackets, but you could write this as a fraction with 1 on the bottom if you wanted to. So either way is good. It's just that if you don't write anything there, then technically what you're saying is it's not this whole thing times that fraction. What you're actually saying there is it's only this times that fraction, which is kind of mathematically incorrect for what you have above. So either way, brackets or fraction like this. All right. Once you've done that, though, it's going to be very similar to what happened over here in that you have a binomial factor that you're going to cancel there. And that binomial factor is that and that entire thing. You're dividing out, you're canceling, and then what you're left with is just tangent over 1, if you wanted to, is just tangent, like that. So you get to the same result either way there, but it's just a different way of getting there. All right, so that's 2 ways to do that. Now I'm going to show you a third way of doing this because I think even though we've done it twice, 2 different ways, there's things to be gained by seeing all these different methods. So this third method here, we'll create some space for it first of all. So this third method is just by doing something that I'd say is very sneaky. It's not really sneaky, it's just if you happen to notice in that original expression that it's 1 plus tangent of theta over cotangent theta plus 1. Since this only involves tangent and cotangent, and those are reciprocals of each other, what you could try sometimes with fractions like this to work with them is instead of what we did in the first 2 methods, which was making common denominators and then adding fractions together and having a fraction divided by a fraction, and then flipping the bottom one over and canceling a binomial factor, what you might recognize here is if you do this, if you multiply the top and the bottom by tangent of theta, you'll see that it's going to work out pretty quickly here. And the reason that is, what we're going to do is we're going to multiply it out on the bottom. If I multiply this times each of these terms, so I'm actually going to multiply it out. It's a binomial over here times a single term, tangent. So if I multiply it out, what I get is, on the bottom here, I get tangent times cotangent. Those things are reciprocals of each other, and reciprocals multiply to 1. Right? Tangent times cotangent is 1. You notice that in the identity for cotangent, cotangent is 1 over tangent. And if I rearrange that thing, if I multiply both sides by tangent, I can make it tangent times cotangent equals 1. So given that this is true, then this is also true. So we can use that idea there that tangent times cotangent is going to give us 1. So that's a 1, and then tangent times this 1 is tangent. So I have 1 plus tangent on the bottom. Now on the top, I have tangent times 1 and tangent times tangent. But in this case, I'm going to leave it in factored form. So I'm going to put 1 plus tangent times tangent. And the reason I'm going to do that is because it looks very similar to what we had up above in the second method. I have this binomial on the top, and I have this binomial on the bottom. And so whatever the value of theta is, I can cancel that out because it would divide to 1. And then you can see I'm just left with tangent. So in a couple of steps by that method, I get there that it's tangent. All right? We're going to look at one more example here. Now I'm going to use a couple of different methods for this one as well. The first method is going to be multiply to clear the fractions. So this involves starting by looking at changing everything so that you have things in terms of sine and cosine. So I'm going to leave the first function as cosine of x. I'm going to change this cotangent to cosine x over sine x. I'm going to change on the bottom there this cosecant x to 1 over sine x, and then leave this 1 like this. Now, what we did in the first two methods of the previous example is we had something that involved an expression on the top where one of the things was a fraction, and the same goes for the bottom. And we made fractions with common denominators and added them together and flipped it over and did all of that. But in this case, I'm going to try something different, which is I'm going to multiply this by something to clear out the fractions right from the start. Now in this case, the only two fractions involved here in this complex fraction, they both have sine as the denominator. So what I'm going to do is multiply the top and the bottom. In other words, this whole thing I'm going to multiply by sine over sine. The reason that that works, you'll see here, is on the top, for example, if I multiply sine times both of these terms, what I'm going to get is sine times cosine is just sine x cos x. I'm just going to write it like that. All right, that was that first thing. And then if I do the second part here, sine times cos over sine times cosine over sine, the sine actually cancels. Multiplying by this on the top cancels out that sine, so what I just have is cos x. On the bottom, since I have to multiply the bottom as well, if I multiply the top by sine x, I've got to multiply the bottom by sine x as well, because multiplying by sine over sine doesn't change the value of what I started with. It's just allowing me to write it in different terms. I can't just multiply the top by sine, for example. I have to multiply the top and the bottom. So on the bottom of this whole thing, sine times 1 over sine times 1 over sine, those are reciprocals of each other, and I just get a 1. And then sine times this 1 is just sine, like this. All right? So the reason that helps now is I have something that doesn't have any fractions involved, and it's going to allow me to move forward and simplify this thing. So you might wonder what you can do here. Now you don't want to start doing incorrect, invalid things like saying, hey, I can cross out this sign with this sign up here, because in both of those cases, that sign is part of a binomial here, and this sign is part of this binomial here. Can't cancel out part of a binomial. But what I can do is I can factor the top, because what you'll see happens here, if I factor the top, what I mean by that is we have a common factor of cosine on the top. There's two terms and they each have a cosine involved. So if I factor out a cosine and I make this sine minus 1 on top, right? And then the bottom I have 1 minus sine. Now you have binomials that look very similar to each other. Sine minus 1, 1 minus sine. Now if you have two binomials that are such that they're just reverse of each other with a minus sign in the middle, you'll find that you can't just cancel them like this, because they don't divide to 1, but what they do is they divide to negative 1. Think of any two things like n minus 1 and 1 minus n. Whatever n is, let's say n was 6. The top you have 6 minus 1 is 5, and on the bottom you have 1 minus 6 is negative 5. Whatever value you put in there, these are going to come out to opposites, which divide to negative 1. So what I can do is I can say I am going to divide that out, but it gives me a negative 1 there. All right? And so what I'm going to end up with here is cosine divided by negative 1, which is negative cosine of x, which is a single trig function there. All right? So that's method 1. Now I mentioned there were two methods I was going to use with this. We'll just clear our space here first. And our second method is going to be one that we used before, which is using a common denominator. So we're going to go through this pretty quickly because we did it in the previous example, but we're going to go back to the spot where we had changed everything to sines and cosines, like that. But instead of multiplying by this sine x over sine x, what we're going to do is make a common denominator there. So since we see that this cos x over sine x has sine in the denominator, we need to make this something that has sine x in the denominator. So we're going to need to multiply this by sine x over sine x, just this one. And the same with this one here, we're going to have to multiply it by sine x over sine x. And what we're going to end up with there then is fractions on the top and the bottom have common denominators. So we have sine x cos x over sine x, and we have cos x over sine x, and then on the bottom, the whole thing here, we have 1 over sine x, and we have sine x over sine x. So that looks a little more complicated, but it's going to work out just the same way here. We can write them as a single fraction on the top and the bottom. And then we can do what we've done before, which is dividing by this fraction is the same as multiplying by its reciprocal. So we're going to change it to the top fraction, but multiplied now by the reciprocal of this. And then we're going to have to do something that we did in the first method for this, which is factor this expression right here. And then we can look to simplify this before we multiply it out, which we can do. In a similar way to the first method, we can cancel this and this, except that we have to realize that it's going to result in a minus 1 because they divide, their opposites, they divide to minus 1, not 1. We can also cancel this and this because we have a sign on the top, sign on the bottom. We're multiplying, and you notice that all we're left with then is this cosine and this minus 1, which is going to mean that what we have is minus cosine of x, which is what we had the other way too. So there you go. Now, those are some long examples, but I hope it gives you an idea of how you can use the reciprocal and quotient identities along with some algebra skills to simplify trig expressions.